Good morning, all. Let's start with today's agenda. I think yesterday we had a discussion on different things like the linear algebra and supervised learning, unsupervised learning. Today's session we will be talking about how exactly we can implement all the things in machine level understanding, or we can have artificial intelligence, machine learning, and deep learning. So our main focus here is to understand how exactly these individual components are working. So before we start, am I audible to all? Please comment in the chat box if you are having any trouble hearing me, or having trouble to see my shared screen. Okay, so all are saying I'm audible and screen sharing is okay. So let's start with our agenda. So today's agenda is, first we will be understanding what exactly artificial intelligence is, what is machine learning, limitations of machine learning, deep learning, what is deep learning, and deep learning applications. I request all participants to please mute their mics. So let's start with the first topic. What is artificial intelligence? So before we start with artificial intelligence, we need to understand why artificial intelligence is required. Let's take an example. If you can see on my screen, I have an illustration of a car having a number plate. So you often see that when we are out at a street, and nowadays online policing or webcam screening is common nowadays. So uh, if unfortunately we jump a signal, then what happens is after some days, or maybe after some minute, or immediately we get a ticket or we get a challan. So if we can look at this analogy, or if we can look at this example, it is not possible enough for a person sitting behind camera or behind that web view and calculating each and every car speed, or we can have eye on signal jumpers or something. So there we need an automatic solution, because though our human brain is processing trillions of information per second, or we can say microseconds, but it is not feasible enough to capture all these images, or to capture all these illustrations together and have a classification of it, whether this is a signal jumping crime, or this is zebra crossing crime, or something else. So there we required an automatic solution. So instead of human analyzing all the images, there is a machine who's doing this task. So what that machine is doing, that machine is capturing that particular photo or particular footage. Okay, there was a disturbance. Yeah. So that machine, or that algorithm, or that particular application is capturing that footage, capturing that image, and converting it into a text. So it will capture an image of a plate, and then it will be forwarded to another machine, or to another subset of that particular software, to understand what is written on it. So basically, it is what it is doing is, to solve the complexity. The machine is capturing the number plate picture and converts it into a text form. So once it is converted into a text format, it is very easy to understand for a machine. And according to information which is fetched by another software, or we can say like API, a ticket or challan is generated, and message or subsequent information is displayed on your email or by SMS or by anything, it will be notified by you. So what is this? This is also artificial intelligence, where machine is having a capacity to think, capacity to analyze a particular thing, capacity to make a decision. Because here the machine is deciding what kind of penalty should be applied. It should be applied for crossing a zebra line, or it should be applied for jumping. So, so are we clear at this point? Have any questions? Have any difficulty hearing me? I'll request all please use their mics.
यहीं पे ऊपर ही है नीचे नहीं नीचे उनको बुला के लेके आओ जरा
Okay, so let's move ahead. Now, what exactly artificial intelligence is? As definition suggests, artificial intelligence is the capacity of a machine to imitate intelligent human
वॉइस नहीं
behavior.
आ रही मुझे बहुत ही हल्की आ रही है
बढ़ा ले भाई अब उसमें क्या
बढ़ाओ
करूं
कहाँ से मुझसे नहीं हो रहा ना
दिसतंय त्यांचं काय चाललंय व्हिडिओ पण ऑन आहे
All participants, please adjust your mics, videos, whatever the AV modes are, so we can move ahead.
पण लगेच थांबताय
So, where we are, what is artificial intelligence? So, artificial intelligence is the capacity of a machine to imitate intelligent human behavior. As this concept is suggesting, what a machine is doing, machine is trying to imitate itself as a human. Now, when this kind of activity is happening, as a human being, we are learning from our childhood. So we are learning a lot of things from the childhood, like we are learning how to talk, how to walk, how to understand the different behaviors of a human, how to recognize humans or other human activities. As not only the human activities, we are learning step by step how to differentiate between the things, living things, non-living things, what to call to a table, what to call to a mobile phone, and so on. So we are continuously learning, and that's why at this our stage we are able to understand each and every component in our environment or in our vicinity. So same as machine, when we talk about machine, machine is not having that much of intelligence to identify each and every component what that machine is able to see, of course, by mimicking our eyes by cameras or by having image as an input, by having audio as an input or something like that, according to our application, according to our requirements or needs. But that machine needs to train more and more than the human. As human is training its mind, or humans are training their minds day by day automatically, the machine needs to train their minds every time with a subsequent data sets. When we say a data set, what exactly data sets are? These are the collections of facts. So when we are trying to what we can say, load machine's mind with all these kind of data, machine is learning out of that data, and now we will be imparting some kind of algorithm, some kind of tool sets to classify that information, to act on that information, to identify a particular things, and accordingly, machine is doing it. But we need to remember that machine is like in Marathi we say sang kame. So what exactly sang kame means कि जिस तरीके से आप उसको बताओगे और जितना आप उसको बताओगे उतना ही काम वो मशीन. So when you say that the machine you wanted to do a particular task, you need to feed a dog, but machine directly जाके dog को feed नहीं कर पाएगा. As machine need to understand first what is feeding and what is dog. So ये जो दो चीजें जब machine को understand होगी, and when we make machine realize all these things, that time we can say that intelligence is imparted into a machine. But again, that machine's mind is created mechanically, electronically, or we can say artificially. That's why we are saying it. This is artificial intelligence. As the slide is also suggesting, AI is accomplished by studying how human brain thinks and how human learns, decide, and work while trying to solve the problem. So here there are some major things. Humans are learning, so the machines are. Humans are deciding the things. So you are making a choice whether you wanted to go that way or not. You are making a choice, but based on what you are making that choice based on history of the actions that you have already performed or the information about that decision, or I wanted to go to Mumbai, so which fastest route I can take, whatever the information I am having, I'm deciding. So the machine is deciding based on the input and the training data that the machine is receiving. So machine is deciding. Then work by trying to solve the problem. So here is the problem solving ability. So human minds are having a problem solving capacity, of course superior than the machine, but how that problem solving capacity is evolved or developed by understanding the failures or a success based on the historical events, incidents, or information which is passed. Same with the artificial intelligence. To make artificial intelligence work smoothly or uh, make that machine perform a particular task smoothly, that machine needs to be fitted with the accurate, or we can say a latest data with a history of performing actions. So that machine will learn out of that and can be available for humans disposal, or whatever the task is allotted to that artificial mind, it will be solving it. Yes. To understand all these problems, to solve these problems, or to decide what to do, we are having different techniques to make machine learn, like supervised learning, unsupervised learning, reinforcement learning. Then we are having a fitting methods, forward fitting, continue fitting, and so on. So we will be discussing it in a bit. So what exactly AI is accomplishing? Outcome of that study is used as a basis of developing intelligent software and the system. Means what? Whatever the trained data or the training we are giving to a machine, based on that we will be creating software or a system. Basically, it is taking that entire information as an input and producing some kind of meaningful task. Not exactly a meaningful task. Saying meaningful task is not fitted here, but we can say a action, to perform a particular action. So, based on the recent approaches, what are the main applications of artificial intelligence? First is speech recognition. Second is understanding natural language, and third is image recognition. When we say a speech recognition, here I wanted to tell you there are three types of artificial intelligence which is available. Let me pull that screen for you. Okay. So there are three types of artificial intelligence. First is artificial narrow intelligence. Second is artificial general intelligence. And third is artificial super intelligence. When we talk about artificial narrow intelligence, it means what? That artificial intelligence or that particular software or a machine having a predefined information which is loaded in their application. So based on that information only, it is giving you reply. For example, chat box. So when you are opening a chat box, in that chat box, particular information about the system or about a particular product. Take an example of chatbot which is available on uh, Bajaj Finance website. So if you can go on Bajaj Finance website, there is a small icon at the left side saying, "Hey, I am Blue,
তো
your
এবার আবার
virtual assistant."
সে এবার হয়ে যাবে
So that virtual assistance is an example of narrow intelligence where some of the product information is already there with that chat. So if you ask about, I wanted to apply for a loan, it will throw you various options. You wanted to apply for a personal loan, you wanted to apply for consumer durable, and so on, whatever the product under that loan category is listed. After that, when you select appropriate option, it is asking you to select one, two, or three. When you select the second option for a personal loan, then it will directly gives you all the eligible criteria list or whatever the document required to process that particular information. So when that information is given to that chatbot, but that chatbot is not able to process that information because that chatbot is developed to give you information about whatever the specific keywords you're inquiring for. Specific keywords like loan, PL, that's the personal loan, car loan, or something like that. Even the information which is loaded with that chatbot according to that keyword. So that narrow intelligence, what that narrow intelligence is doing, that narrow intelligence is performing text mining, voice screening, or trying to find out a particular keyword. Like you're searching on a Google, you type a particular keyword, according to that keyword Google is giving you the information. But yes, Google is not a narrow intelligence, it is a general intelligence. So this narrow intelligence itself a narrow in replying the things or itself having a less or limited information about your task. If you go and ask that virtual assistant, "Hey Blue, how are you?" It will not going to reply you back. But in the case of artificial general intelligence, that artificial general intelligence is having more superior ability to perform tasks than the narrow intelligence. Now, what are the artificial general intelligence? For example, if someone are using Apple phone, then Siri, virtual assistant is there. In our Windows, Cortana virtual assistant is there. In our Android phone, OK Google, Google's voice assistant is there. So these are the examples of general intelligence, artificial general intelligence, where these virtual assistants will mimic themselves as a human and can predict, or not predict, but can communicate with its owner or with its what we can say a participant who is going to talk with that particular general intelligence. So if I open up my Siri, I'm using Apple phone. So if I open up Siri and ask Siri, "Hey Siri, how are you?" Siri is going to reply me back, "Hey, whatever the name I have given RX100." So it will reply me back, "Hey RX100, I'm good. What about you?" So once I'm starting conversation, that general intelligence is trying to recognize my speech, trying to find out the keywords, try to convert those keywords into a text, and try to find out more information related with that particular keyword. So as Google is doing in Google's voice assistants as well as in Google search engine, when you type something on it, whatever you will be typing on it, it is giving you some kind of suggestions out of it. So uh, Just sharing another screen. Okay. So I'm going on Google. Is my all three screens are visible? Now my Google is also visible to all.
Yes, sir.
Okay. So some participants are not able to hear my voice properly. Maybe it is because of the network issue at their end or at my end, but some are able to listen it clearly. Okay, great. So on the Google, if you observe here, I have just clicked on the search bar. Once I clicked on the search bar, you can see all the recent searches what I have made. I have searched for PyTorch, I have searched for modern co-workspaces, modern co-working space, GFI trial login, and so and so. So this is what this is. Stored information what Google search engine is acquiring from my cookies. So cookies are the files which are storing information about your login screen, login information, sessions, and everything about what you are searching online through browsers, permanently or temporary, as per the requirements or as per the users, what we can say, configurations. So this is the information what Google is trying to get from its bots, or we can say uh, crawlers. Crawlers are the artificially made software programs which is crawling for different keywords and fitting to a Google search. And Google is making profit by showing you ads. So uh, these are the things what Google is capturing. But the more important part is how exactly Google is having artificial intelligence or machine learning platform in the building. Once I type for ML or I'll type for machine learning. So once I'm typing for a machine learning, forget about the recent searches what I had did, but here at the black color, Google is showing some suggestions. So these suggestions are totally based on the keywords what you are searching for, and these keywords are analyzed by the machine learning platform. Basically, this machine learning platform of a Google is a there's a second type of machine learning platform which is artificial general intelligence. And what that artificial general intelligence is doing, the artificial general intelligence is capturing all the keywords and fitting into the Google search, Google's database for appropriate results, and then Google is fetching appropriate results, whether that keyword is available in URL, whether it is available in description, whether it is available in title, and so on, and providing that information to viewer, as well as that information is stored in Google's framework for creating a Google profitable ads and showing you these ads. Now, you won't be able to see some ads because I'm having ad blocker installed on my browser. Let me turn it off. So once I click machine learning and hit machine learning, you can see all these kind of ads. Now, by analyzing a machine learning, there are the two main keywords. One is a machine and second is a learn. So, based on the recent searches, Google is showing you
नवीन वाला
appropriate
आधार कार्ड
results.
और है ना
Machine learning
नवीन
for
वाले
what?
आधार
Machine
कार्ड और
learning
फॉर्म
for learning purpose, to
मतलब
implement
वाला
something,
ना
and so on, based on that
फॉर्म
keywords. So now, if I type only machine, remember these machines or these softwares are सांगकामिक. जेवढं तुम्ही त्याला काम देणार आहात तेवढंच तो सर्च करणार आहे. त्यामुळे मी जर इथे मशीन सर्च केलं, so you'll see a general information related with machine. Now it is not giving you the appropriate answer or what you desire, that kind of. So this is the beauty of machine learning. Machine learning, what it is doing, it is capturing all the events what we are getting. Now here in Google's point of view, whatever research I have did or whatever the observation I have made, Google is doing reinforcement learning. Where in a reinforcement learning, your agent or we can say a machine which we need to train is analyzing its environment, analyzing its vicinity, and trying to learn from try and error basis. So, for example, if we are learning Python for a first time, definitely we are making some mistake. Though syntax and everything is front of us, but we forgot to give a semicolon or we forgot to give a comma or a dot or something like that. Silly mistakes we can say, but we may make mistakes. So we are learning from that mistake. From a childhood itself, human is learning in a reinforcement way, where it is a human tendency where we say something की हे तुम्हाला नाही करायचं. So when we say you should not do this, we always intend to do that. So for an example, nowadays in the lockdown period, government is saying do not roam around or do not come out of your home until it is necessary. But still, some people are going out for seeing how lockdown is working or how empty streets are looking so far. So this is what this is also a reinforcement learning where we are learning from our mistakes. We are learning from our curiosity. So these are the products or these are the elements which makes reinforcement learning much better than the other type of learning that like a supervised or unsupervised learning. But it is again a debatable question whether always a reinforcement learning work for a machine or not. My opinion, yes, it is working, but depending upon what kind of operation you intend to perform through that machine. If you are having an autonomous robot to take care of different things, let's take example of space missions. So you are having a robot to calculate a trajectory to a particular planet or repair some satellite failure at the moon or something where human cannot go outside every time and survive in that cold temperature of the space, where these robots or these machines will reinforce themselves by learning the environment. By learning the environment doesn't mean that we are pushing that machine into a totally strange and totally what we can hostile environment. But yes, of course, we will be training that machine particularly with whatever the information currently we are having. As we need to remember that machine will try to look back for a history or whatever the information they have collected in their data sets. So we will be pushing them with the data set what humans have collected the information. Based on that, machine will enter into a different environment and try to analyze the things and try to map those things and will learn out of the errors. So we will be talking about the reinforcement learning later on in our slides. Let's continue with the slide first. So, okay. So everybody clear so far?
Sir, please can you explain AI super intelligence?
Sorry, who was that? I'm not able to hear. Please drop your comment in chat and take it properly. Okay, here I'm having one question. Search some data on Google. It provided me info, but when I use my machine, Gmail, some info that we can pass save data, but logging the Gmail. Is it related to machine? Yes, of course it is related with machine learning, but it is not directly related with the machine learning, but it is called something like capturing your search habits or capturing your information through locked in SSO that we are having single sign on by that. But of course, machine learning platform is working to analyze your information. So once you have logged in into a Google's Gmail support, you automatically get logged in into various services which are offered by Google itself. So when you logged in into Gmail, automatically logged into accounts.google.com and associated all the services. When you search something on the Google, then Google is trying to capture all the keywords what you have searched, and it will be passing into its machine learning algorithm for a specific requirements. As you know, that Google is making profit or Google is profitable by showing ads. So these all information is again travel back to the Google search engine for analysis purpose, Once the analysis is done appropriately, it will show you the ads or whatever the information you want to see that. So once you leave that particular machine and log in into a second machine, but still the instrument of capturing the things are your login. So once you log in from one app laptop to another or from your mobile phone to another phone, at that time that will be creating a checkpoint and it will, whatever the stored information uh, your ID was having, Google will show that information to you, suggesting all those parameters to you, suggesting that okay, you have searched for all these things, might be you will be requiring this information right now. So here are the ready information for your disposal. So that way Google is interacting. And again, yes, it is the trick to get the search habit, click habits, where you are clicking. Even Google search engine is tracking their users on how much time you have spent on a particular website. So if you go on the Debug2's website, how much time you have spent on the Debug2 website. Now, how it exactly it happens because of the Google's analytics. Now, most of the users are having their SEO implemented. So to work with the SEO, you need to have a Google Analytics installed. So those Google Analytics is completely tracking your each and every page. The Google Analytical code or API, or we can say nowadays everyone is working with webhooks, as webhooks are more secure than these API. So these webhooks are already present on each and every page which is uploaded. So suppose I'm not sure about the Debug's website, I'm just giving you an example, or take my website's example, Softtech Data Security website. So in my website, I'm having Google Analytical code with me. I'm having a webhook. So Google is trying to capture all the hits. It means clicks on each and every page. So once I'm logged in into my Google Analytical framework, I'll be able to see that past 5 days how many clicks have happened on my particular page, by which IP address and in which environment, or from which side or the which area of the world. So this kind of information I can collect. Okay. Yeah, I'm about to go on the super intelligence. Now, the super intelligence means super intelligence is a subset of a human brain where you have already applied a majority of intelligence on a machine, and now machine is in a self-extract mode where reinforcement learning faculty, where machine will be deciding on their own by understanding the environment. I'll suggest you to watch a movie, Kill Switch. Kill Switch movie is a science fiction movie based on the super intelligence, where they have made enough what we can say, uh, military robots who are reinforcing themselves. So they are copying human behavior. They are analyzing that human behavior, and they are making supervisions on humans, and they are making some changes according to their requirement and performing them. For example, in that movie, there was a one shot that 5 to 4 army men are there, and yeah, that movie's name is Kill Switch. So in that, there was an say, uh, there was a hostile situation where 4 to 5 armaments were fighting with robots. Their task was to engage with robots and try to take down those robot targets. So those robot targets were a decoyed robots which are moving from one place to another place with a predefined path. And these RB-men need to hunt them and hunt it down. And the another robots were superiorly intelligent than those predefined path robots. They are analyzing each and every movement of those soldiers and those robots, and how exactly soldiers are taking position, in which frequency they are firing at those robots, and what kind of ammunition they are using, how they are deciding to go from one place to another in a heavy shelling or heavy fire from those robots. And they are analyzing those tools, and they are keeping that record. And then in another shot, they have deployed their another robot uh, deployed army, where they are mimicking the exact positions of those armies, those soldiers. and they are attacking on them with the more superior way than those are technology, the humans were technology. So this is a perfect analogy for a super intelligence, where we can almost say that there will be no gap between human thinking and a machine's thinking. So this is in a process. So again, it is a debatable one whether we should go for a super intelligence or not. Because for a super intelligence, we are having advantages, like we are having most of the cases disadvantages as well. So maybe you're seeing some science fiction movies or science fiction seasons on the Netflix or something. There are a lot of seasons like Dark Matter or something. Those are having human robots. They called it as androids. So those androids are behaving like a humans. So that is a super intelligence. Clear so far? Okay, great. So again, moving on our example. So here is a speech recognition. So here is a speech recognition where the machines will understand the speech, it will recognize a pattern of speech. Nowadays, this speech recognition is widely used in some fun application. Like you must be remembering Talking Tom application, where Tom is mimicking ourselves, some funny noises out of it, or exactly repeating ourselves in a funny way. So that is also speech recognition. So there, that software which is having a limited intelligence is capturing your voice, taking the voice, what we can pitch, not the speech, pitch, and analyzing that pitch, recording it, and reproducing that pitch into a predefined speech or predefined manner. So that is also example of a skill artificial intelligence and machine learning. Then nowadays we are having more sophisticated speech recognition. Like Cortana is having speech recognition, Siri is having speech recognition, our Google voice assistance is having speech recognition. More or less, law enforcement agencies are also using speech recognition to understand whether that person is that only the person who is recorded that voice. So maybe in a court of law, if you wanted to testimony a particular thing with the audio video aid, then every time a defender is always raising a question about the authenticity of a voice or a video in that AV, in that particular film. So there, speech recognition using artificial intelligence is able to work it out. Understanding the natural language. Now, what the understanding of natural language is, every time when we speak, we are having a habit of taking some kind of pitch levels. So, like, it is not always same. Everybody is speaking in the same pitch, in the same manner, same accent. So, I'm having a different accent. Someone is else are having a different accent. So, understanding the natural languages. Even in India, there are thousands of language speakers. Even in Marathi also we are having a different ways of speaking Marathi, different ways of speaking Hindi, different ways of speaking Bengali, different ways of speaking Kannada, different ways of speaking Malayalam. So in that all way, a natural language means what machine needs to understand how the human is giving voice or human is giving tone. That is a understanding of natural language. So for that, we need to work on the subsequent data sets of different voice patterns, different pitch patterns, different things. So that study and that research is going on. Even this is perfectly applied also in you can see in your voice assistants itself, Google, or even if you have your map, Google map ready with you and you targeted some place, then that map is surrounding with what you can say signs and everything, and that map is giving you answers in your natural tone, not at the machine level. So that is the understanding of natural language. Or maybe understanding a natural language in a theoretical way, syntactical way. Third, most commonly used machine learning or artificial intelligence is analyzing and detecting faces, that is image recognition. Not only with the faces, but object also. So this image recognition, object recognition is a very important part in a mode of learning the machine. Because by all visual aids, we can train machine to identify different things, to identify laptop, then water bottle, then another robot or something, or a human, non-human thing. So image recognition is also a very good area where the artificial intelligence is done. When we talk about artificial intelligence or deep learning or a machine learning, some uh, some are saying that these all are same. No, these not all same. Some says that artificial intelligence is apex one, and then it inherits machine learning, and machine learning inherits deep learning. No, as my point of view, or whatever the observation we had, these are all are the subsets of each other. These are not in, or it is not inherited by anyone, but these are the subset. Subset means what? To achieve artificial intelligence, artificial intelligence means the final task, the final, what we can say, software or the hardware or the final action what that machine is going to do. But on what basis? So artificial intelligence required input by machine. So machine learning is a subset of artificial intelligence. So the question comes: artificial intelligence is uh, rely on machine learning, or it is dependent on machine learning? We cannot say dependent, but yes, it requires some information, which is a pre-processed information, to be given to a software. Based on that, that software will be deciding something or predicting something. That is artificial. So machine learning is a subset of artificial intelligence. Again, machine wanted to perform sorry, wanted to perform a particular task in a flawless manner. So every time when we code something, we expect that code should return us desired output with minimum errors, or we can say zero errors and zero overload. So as we are training our machine, that machine need to perform its activity flawlessly. So to give that machine a flawless input, or train that machine into such a manner that it will take a flawless input and gives you a flawless output. Deep learning means learning a particular thing in a very inherited way that is required for a machine learning. So that's why artificial intelligence, machine learning, and deep learning are the subset of each other. So even in the deep learning, that I forgot to mention, that deep learning is having neural networks to perform a deep neural learning task. So, what is a neural network? It is inspired by human brains. So, as human brain is thinking, as brain is understanding the things, these uh, machines are also able to mimic it, or machines are need to able to mimic it, not are able to, but need to mimic it, or adopt those functionalities to produce a task particularly. So that is a deep learning. So let's focus first on what is machine learning. So if you can see that evaluation chain, there's an illustration. What this illustration is suggesting that we are having a narrow intelligent machine over here. This is the narrow intelligent machine, then we evolve, then we evolve, then we evolve. And finally, we will be achieving super intelligence in a such a way that we can create a human-like robots, or the humanoids, or androids, and they can maybe there is a debatable question, they can replace humans or something. So what exactly machine learning is? By definition, machine learning is a subset of artificial intelligence. It focuses mainly on the designing of a system, allowing them to learn and make predictions based on some experience, which is which is a data in case of machine. Now here we need to focus on three things. First is machine, second is prediction, and third is experience. Now when we say machine, machine requires input, In order to process it flawlessly, you require to have a proper input. Then predictions means what machine is going to decide whether to perform this task or not. Prediction means if you ask machine by providing some kind of information, like if I wanted to see that I'll be making a profit in my next quarter or not, I need to give software or that machine with all the available financial information in stock material, out of stock material, sell, purchase, and everything. Based on that information, whatever the model we will be creating, whatever the algorithm we will be pushing it into, it will create a prediction. It will calculate it and it will say that okay, maybe in next quarter you will be having a loss by how many percent? You will be having profit by how many percent? So those are the prediction. But another thing, the third most important part is experience. Now, experience in machine terms, what these are the data or these are the data sets. So once you created a data set flawlessly, you provide that data set, it means that you are giving experience to that machine. Yes, these are the financial reports of my last quarter, last 4 quarters, last 5 quarters, last 3 years, or last 5 years. So by that, the more the data you train to a machine will train itself by more data. It will create a more significant output. It will give you more accurate output. So in a nutshell, artificial intelligence is a technique which enables machine to mimic human behavior. Machine learning is a subset of a AI which uses statistical methods to enable machine to improve with the experience that we already talked. And deep learning, which is a subset of machine learning, which makes the computation a multi-layer neural network where it is physical. We will be getting on the deep learning in a couple of minutes. Now, how exactly machine learning works? Now, in a different situations, machines are getting fitted by different types of data. As machine in Sankama, so you need to give them uh, machines data accordingly only it will be going to provide you the output. If you give it wrong financial information, of course, the result may be wrong. So training data, now here is a principle, train, split, and test. Now what train, split, and test is, more the training data you give to a machine, more the learning machine will do. Now machine needs to perform some kind of testing on the learning application. So whatever I have learned, I will be throwing my knowledge, performing into my test series. So I'll be having examination, something like that. So I'll be throwing my knowledge out of that. So whatever the numbers I will be getting from that examination, by that you will be determining okay how much accurately I have learned it. So the accuracy makes that machine or that model in a continuous perfection way. So that accuracy, how will we achieving that accuracy? By testing that figured information. So training a data, then we will be training the algorithm itself. So we will be creating such an environment where it will be getting trained. Then we will be putting some model data also, as there are the questions. Like some are easy, some are hard, some are unquestionable. We cannot answer it something or out of the syllabus something. So these kind of hurdles we can put into the data, and then we'll train again that particular machine, and then we'll try to solve it with the different kinds of machine learning. Once those algorithms are fitted with all this information, created an output that called as a prediction. If that prediction is acceptable in a manner, that means that particular machine is perfectly trained and we can use it into our environment. Otherwise, we need to train it. Sorry, I didn't see your raised hand. Please write down your question. Anyone is having any question so far? Okay. My pace is good. My pitch is good. Everyone is understanding. Now moving ahead, uh, as we mentioned earlier, that there are three types of understanding the machines or training that machine: supervised learning, unsupervised learning, and reinforcement. Let's see one by one. Okay, great. So, machine learning and a supervised learning. So, this is a simple analogy or a simple flow chart of a supervised learning. Uh, Now, in a supervised learning, here is our final agent, which is raising a hand saying that, yeah, it is an apple. So, how exactly that machine is able to distinguish apple from another fruits? Now, how exactly it is doing? In a supervised learning, we are having raw data which is having a labeled information. Labeled information means what? Okay, whatever the fruits I am providing, in this example, we are having a red, bright red apple. So this is an apple, this is a banana, this is a pineapple, or this is a watermelon. So whatever the fruits we are having, we are labeling them, whatever the information we are having. So it is not always the correct label. Someone writes pineapple as a jackfruit. Maybe that time machine will understand, okay, this kind of fruit is called as a jackfruit, not the pineapple. So kind of thing. So we need to always remember that this data set needs to be focused. So whatever the data we are inputting to a supervised learning, that supervised learning data set is having a labeled information. So in this information, suppose we are having input raw data as apple, then that will be passed on to a supervisor. Now, what is a supervisor? Supervisor is a developer, or we can say a moderator who is developing this algorithm, or developing, not we can say algorithm. Yeah, I'll be getting into that how exactly this model will be validated so far. We will be seeing some practicals as well. So in that you will be getting clear out. So, in a in that supervisor or that developer is doing this training stuff. So, this input data or the raw data is inputted into the data set. So, this need not to be created by Python or R. It can be in a simple Excel as well. So, we can create a data set, and that data set can be implemented into a algorithm of a machine learning, what we will be getting SPM, KNN, or so forth. So whatever the algorithms we will be getting, that will be put it into those algorithms. And maybe we can say that my desired output is this, and then that algorithm will process it. The processing of the info, yeah, of the particular information, it is what processing information means whatever the data set we have created. Now, how exactly we have created a data set? We have created a data set based on the dimensions or based on the different elements or based on the different, what we can say, modules. Elements, dimensions, module means what? These are the sub areas or distinguishes where we can understand it. So, in a particular this case, the apple, what kind of I'm asking question to everyone. What kind of event? Sorry, not event. What kind of dimensions you can give to it, or what kind of things you can do? Right? Color, shade, size. Yes, great. So we can have dimensions like weight, size, color. Then color, it is red, chili red, or it is gray red, or something like that. So based on that, based on that, what will this processor will do what this processor will do processing of this data set more accurately. So by that, this model is getting trained. Okay, whatever the fruits I am having, we are having different sizes of a fruit, different color, different characteristics of those fruits. So based on those characteristics, okay, if it is a chili red having size of 1 cm to 3 centimeters, having a shape of a oval or a round, then it is apple. Or if it is a banana, then it is a cylindrical shape and having a color with yellow and dots, red dots or black dots on it or something like that. So that is a banana. Same as with pineapple, same as with watermelon or something. Even we can add one more characteristic as a test. How that fruit like on a test. So test is also can be a parameter. So by all these parameters, particular this particular model will get trained, and then that model will get trained depending upon the input data. Now it needs to be tested first whether particular things have graphed properly or not. So we can throw a different apple. Now this apple is in a green color. Now, what machine will do, color will not match over here. It will discard that parameter, but it will check for the other parameters, size, shape, and everything. So those are matched. So that is a perfect match, or that is a nearing match, and it will say that yes, it is a. It will not say that it is in green color. So lychee is also green. So it is not saying that this is a lychee or this is a grape, but based on the other parameters. So by that, if we get a desired output, like here, the desired output which is shown, if we get a desired output saying that, hooray, yes, it is an apple, that means that we have trained our machine perfectly with a particular thing. This is a supervised learning where we are inputting a labeled data, where we are having parameters which are set. Here so far, any question, any doubt? I'm very bad with the annotation, so please bear with me.
bad with something बोललो. नाही काहीतरी दाखवायचं चाललं. ती लिहितोय ना ते सर्कल कसे वाकड तिकडे.
Okay. Just give me a 2 minutes, I'll be back. Just give me a 2 minutes. Okay, thanks, guys. I think I'm having some questions. What will happen if there are same parameters for different tools? Yes, so that is the ambiguity where human intervention is required, as machine is not that intelligent. So we are having some limitations on machine learning, as machine cannot understand um, what we can say a concurrent data or a large amount of data, because it needs to be processed every time in a processor or in our model. So if we are having same parameters for a different tools, maybe a first parameter which is having a more accuracy or having a more closer view to inputted test data, it will be present as a output. So maybe, but accuracy is a question in the line. So that time the supervised learning will not help us. We need to move to a more sophisticated way. We will be training our machine to a reinforcement learning, where though we are having same parameters for a particular fruit, but that machine is learning out of their mistakes, try and error basis, so it will distinguish between all these things. Maybe in a, grapes, we can say that there are different types of grapes which is available. So that kind of. If you go with the supervised learning, yes, it will tend to a less accuracy rate, or we can say a moderate accuracy rate. I'm having question that in supervised, both input and output are considered. Output is already finished product, so output will not get considered, but input is always will be considered. If we are using in a deep learning forward feed method, then output is also going to be considered. As in reinforcement learning or a deep learning cycle, that output can be an input for some processes. Like if we are driving a car, once we are trying to learn a car particularly, so our instructor is taughting us that how to gear, how to brake, how to pedal, how to accelerate, how to handle your steering, and out of that you are learning what you are doing a reinforcement learning, you are improving yourself, and after that when you are trying to look out from your car, you are learning that environment as well, and accordingly you are adopting all those techniques in your body. So this is a reinforcement learning. Their output, your paddling and your car is moving. That is also output. So that output can be considered in what we call reinforcement learning, but not in the supervised learning. But yes, depending upon how you are using. What types of input can be given to a model to train it? You can give input according to your requirement. If you wanted to calculate, you can say profit and loss for your particular segment. If you are running a business and you want to get that profit and loss, you can give input as your financial statements. If you wanted to classify some images, you can give input as, but those need to be labeled one. Right here, I'm having a different example as well. So here in this picture, what we are having some characters which are ducks, characters which are not duck. So we have labeled them. These kind of these what we can say inputs are different in color, different in shape, different in size, different in every characteristic. But these all are belongs to one category, that is. Now these three. Now these three are not in a dark one. So what will happen in this case when we train our model to identify which are duck and which are not? It will simply classify them. It will simply run all those parameters. And when we give this another picture as input, and we ask our model, tell me which is this one, this is a duck or not. It will simply says this is not a duck based on the characteristics what it is having. Like, they are having a nose, how they are having their feathers, how they are having their legs, and so on. For graphs, I need to search for, but I don't think so. We can give graph as an input. Supervised learning. How you will be defining graphs with a different characteristics. Limitations of supervised learning, of course, main limitation of supervised learning is your data set. If you are having a faulty data set or you are having some parameter missing into that, of course, your model will get trained with the less accurate. tend into a less accuracy. So, and supervised learning, we can have algorithm like linear regression, random forest, support vector machine. Most probably in supervised learning, most favorite one of every data scientist is support vector machines. So there are some use cases of supervised learning where supervised learning can be uh, implemented in virtual voice assistants like Cortana. When we ask Cortana, "Hey Cortana, who is your dad?" So you can try it out at your machine if you are using Windows machine. Just turn on Cortana and ask Cortana, "Hey Cortana, who is your dad?" And what kind of funny answers you are getting. Most probably, Cortana will look into Cortana's database or the history of searches, and it will say that technically it is Bill Gates. And when you ask Cortana, who is Siri? Cortana will answer it. It is a competent voice assistant. So kind of thing. So here it is what this Cortana is loaded with a labeled data, but again it is a debatable one. Cortana can be in unsupervised or reinforcement learning, depending upon how exactly we are implementing the things. No, we don't have any restrictions for a character sheets. We can have as many as we want a character sheet, but it needs to be defined perfectly. It needs to be defined properly, and all the other elements, like if you're inputting fruits, and fruits are having 6 characters, so all the fruits what you are imparting, those needs to have those 6 characters. If you are missing any character in any place or any column, then that will be treated as a faulty. So now, if you are having a faulty data set, what will happen? It will happen like your model will get trained with a less accurate data, and maybe it produces the less accurate predictions. Okay. So weather apps can be a supervised learning. So weather apps are learning by concurrent data where they are receiving input from maybe from a satellite, GPS satellite, geolocation satellites, or what we can say information which is available on national portal. So by that they are giving the information, and even they can learn from their recent history as well. That 5 minutes before there was a fluctuation in so temperature dropped by -1 degree or dropped by +1 degree. 1 degree makes a lot of difference, but just I'm giving you the example. Yes, an equation can be an input, but we need to see that in a data set, if you are giving an equation, they needs to have some characteristics which needs to be different. As I said, your inputs are totally based on what kind of application you wanted to perform through that machine. So if you are having a machine who is producing a mathematical model or mathematical output, then of course you need to have your equations ready. Your equation needs to be in a data set. If your model is going to train for image recognition, then both the things, statistical equations as well as the image representation, both needs to be. So it is totally depend on how exactly you wanted to perform the things by that machine. Then another example of machine learning could be a biometric scanners. So biometric scanners, let's take example that you can have your fingerprint, iris, or facial recognitions and everything, where you can have your characteristics recorded into that biometric machine, and that machine every time analyzes the new captured image or analyze the new face or analyze new captured what we can say that iris and calculate the best possible result, and it can able to identify it. So that can be a supervised learning approach. So there you can have labeled information, like if you are giving a thumbprint, then thumbprints are in these characters. So if these characters are present in a captured thumbprint, of course it is a validated user. Otherwise, one of the character is missing, then it is invalid. Or you can set the access control on it, how much characters you required by out of 10 or out of 5. Out of 5, you need to require at least 4, at least 3, or 10, at least 8, like that. Labeling a huge data will not create a problem, but create a computational hiccup, right? Like you required a good amount of CPU to process it. As when you are training your machine is learning. So machine is burning its fuel as well. So you need to give it a good fuel, good RAM and good CPU. Then a large number of data can be no problem. But concurrent big data is a problem. It is a problem for entire machine learning process, because to compute that kind of data or that kind of computational environment, you required a huge amount of processing power. So if you are having a huge amount of processing power, then you can, yes, you can use a ML algo for labeling data, but you cannot use a direct algorithm according to your environment and according to your application. In the banking area also, we can use supervised learning to predict the credit card worthiness. So if you are going to apply for a loan, then there are the eligibility criteria listed. So you need to have CIBIL score out of this or that or so on. So you can create a data set, you can create an Excel sheet having gains and the applied loan and all the characters and every category, and you can put that into your supervised learning algorithm and trained machine to identify. So already these banks are doing it. So if you go on paisabazar.com, if you go on any other non-banking financial or financial banks website, like you can go on Kashi, you can go on Bajaj Finance, and so on. So they are having their electronic eligibility criteria application, where you will be putting your all information. They will ask you for your document as well. When you provide those documents, even your bank statement, and when you say that, yeah, I'm salaried, I'm having a 1 lakh rupees of salary per month, and I have applied for 10 lakh rupees a loan for 3 years, then it will automatically check your salary keyword into your provided bank statement. So by having these all labeled data, you can train that application, train that machine to analyze all these stuff and can give prediction. Yes, based on your recent search, out of 10, you have marked as out of 10, out of your marked as a 8. So you're eligible for a loan. You're marked as a 5, you're not eligible. So you can have that. If you select a significant characteristics, of course, it will reduce the parameters, but it will be what we can say a closed loop. So if you wanted to search for a particular, like take a very general example, flowers type. So you provide a particular characteristics only. You provided 5 characteristics out of 100. So all those 5 characteristics will be worked as the normal one and can predict based on that. But we cannot say about the accuracy. It is totally depend how you are training your machine. So if you forgot to mention any important characteristic which determines a big difference in your accuracy, then of course your accuracy is less. I didn't get that question. Feature engineering. I guess. Yes, of course, we can have question answer sessions. Okay, in a hospitality or a healthcare or as well, we can use supervised learning. So I'll be taking all these major examples toward unsupervised and reinforcement learning as well, because these industries are very vast in nature. So they can be they can be in a variety of stuffs can be included into it. So we will be exploring it one by one. So supervised learning in healthcare industry, yes, we can predict patient remediation rates. Means what? Whatever the patient data we will be having, we can remediate. For example, take example of COVID-19. So if we analyze the COVID-19 symptoms, we can train our model with that symptom, and we can ask a particular patient to input their type, whether that patient is having cough, cold, fever, or something like that, and we can ask them to provide some numbers, how much cold you are having, based on some criteria. I don't know about it, but yes, there are some categories, because I'm seeing some applications which are predicting those things. Even your say two app also doing the same. I don't know. And another one is how much temperature you are having. You are having a say, a fever in the last few days or not. Based on all these criteria, we can predict whether the patient is suspected to COVID-19 or not. So these kind of patient information we can get, or we can get the remediation ratio by doing this treatment, by availing these drugs. These many patients out of these patients are already treated and they are healthy. So we can predict those patient remediation rate for the patient. So, and this processing and this processing on a big data or a bank, and it will be learning. So no, learning will not be a slower, but of course computational task, if you are not having adequate hardware with you, then of course the prediction time will take more, as usual, because it needs to be processed. So learning will not get slow. Is there any space in your lecture for I didn't get it. If you wanted to ask that how to write an algorithm or what exactly. Okay. So moving forward, in the retail industry, as we already discussed about, if you wanted to see profit and loss, we can use supervised learning, or we can say that analysis of a product, what kind of product or which company's product is getting sell more in other fashion. Like we are having Patanjali products, we are having Himalayas products. So whichever is more likely to be purchased by customers. So that kind of learning also can be done in supervised prediction. Can be done in supervised. Right, see the unsupervised machine learning approach now. Now, in the unsupervised learning, what we are actually having is we are having a raw data, but we are having an unlabeled data. So these data, it is not categorized, it is not having a proper input, maybe a fault input, or not having adequate information about it, and that is pushed into algorithm by interpreting it, okay, maybe this can be an apple, maybe this can be a banana, this can be a mango or something, and that is pushed to the algorithm. We don't have any information about what kind of likely output it will be. We don't have any information about training data set or accuracy of a data set. So in that model will be getting trained. So what happens to the supervised learning? The beauty of supervised learning is in unsupervised learning. The beauty of unsupervised learning is those data will be classified into the cluster. So machine itself learn out of the characters, or try to identify some characters. Like it is having red in color, so all red elements will be kept aside. Yellow, all yellow elements will be kept aside. Okay, size, it is a 10 centimeter, all 10 centimeters will be kept aside. So that kind of and finally it will produce an output like it is having a same characteristics, or we say having same characteristics elements into one cluster. So they will be having those model trained out of that. So taking this information, this analogy further, and getting back to our cartoon characters. So here if you can see, we are having ducks, non-ducks, rabbits, then what species it is, I don't know, that unsure with us, and we don't have any label. We don't have any kind of information about this. So in a model, what it will do is, depending upon the basics criteria, depending upon the what we can say, same characteristics, like these two are same characteristics, like they are having similar legs, they are having similar nose, they are having similar wings. So based on that, they are clustering. So like this is the rabbit, so they are having this fluffy ears and big foots and all. So depending on that, these clusters are made, and then that data is classified, and then further the data is analyzed and predicted based on the machine. So in unsupervised learning, we are having Apori algorithm, K-means, and hierarchical clustering. Hierarchical clustering and K-means are the most commonly used algorithms in every type of unsupervised. And what are the use cases, or how we can use this unsupervised learning? Let's suppose your friend invited you for a party in a club, and you went to a club, and only you and other two or three friends are there, and other people are there. You know only two or three. Yes, there are some cases where supervisor and supervisors can be applied. This is the actually the best case, the club environment, the party environment, the best case for supervisor and supervisor. That I'm going to explain you right away. So you are having your friend and another friend. You only three are known to each other. So basically, these are what, these are the supervisors. These are the labeled data, and others are unlabeled data. So how will you distinguish whether these are known people or not? You start analyzing people's behavior, what color they have, then what type of clothing they wear, what type of haircuts they are having, what kind of dance move they are doing. Is there are any person who are having cap or not? Like this buddy is having cap. So having cap or not? How many of them are wearing t-shirts? How many are wearing which kind of clothes? So you start clustering them. Apart with those clustering, you're having your friends as well. So you're keeping those into a one cluster, that those are the known clusters. So here you are training yourself. So if you put a machine over it, machine also doing the same. Machine also doing what? Machine are having historical data. Yes, this is my friend Ameya, this is my friend Amol, this is my friend Kanchan. So these three are there. This is my friend Ankita. These four friends are there. So these four friends are mine, which are known to me, so it can be a supervised learning. So if a particular thing need to be applied to those person, of course I'll be applying it perfectly. But what about others? So I start making their clusters, how they look, how they dance, how they wear clothes, if they're any cap, or they are having funky hairs or not. And based on that, if I wanted to ask, I wanted to call, or I wanted to distinguish how many are there who are wearing cap, so I can immediately pull it out. So in a machine, if I wanted to ask a machine that go and serve this liquor to only person who is wearing cap, then machine will do, machine will pre-process, machine will take this pre-processed information, test it again for inputted data. Inputted data is what I need to serve liquor to only those person who are wearing cap. Cap is the inputted data, so it will try to find out a cluster who are having caps, and then that machine or that robot will go to them and serve the liquor of 2x. Okay, I'll explain you this from a starting. So the this party event is a best example for supervised and unsupervised learning, but it is more into unsupervised learning, as your friend have invited you for. Yeah, I'll about to get it for the algorithms in our practical session, so don't worry about that. Just first understand how exactly these functionalities are working. So, getting back to our example, this is the best example for supervised and unsupervised both type of a learning, where your friend have invited you for a party. So you and your other four friends are there. So of course, these four friends and you, including you, five people, unknown people. So what you will be doing, you will be having all the information related to that known people. So you will be putting into a site, you will be creating a cluster of it, but not the cluster based on the parameters of what you will be applying for the rest of the unknown people. You will be not judging your friends based on color, based on clothes, based on cap, is there cap or not, or based on haircuts. What simply you do, you check for the pre-processed information. Yes, these are my friends, and you kept them into a separate cluster. That these are the known faces. These are the known persons. So this is a supervised learning. So whatever the application I wanted to apply, I wanted to offer them a leaf, or I wanted to offer them a food or something, and I will be directly applying them because I know those persons. What about the unknown persons? Like there are hundreds of persons who are dancing in the floor. So at that time, I'll be start distinguishing them. Start distinguishing based on the color, based on the color is more resist, but machines do these things. So based on the color, body language, haircuts, what type of clothes they are wearing, uh, how they are looking, how they are dancing, pose of dancing. There are a number of parameters we can use. So we can limit those number of parameters. We can limit them for 4 or 5, and we can train our machine. Now our machine is trained with labeled and unlabeled both the data. Labeled data for our friends, unlabeled data which we have collected right. So we have clusters, like we have clusters for t-shirts. So the persons who are wearing t-shirts are kept into one cluster. The persons who are wearing saris, of course, sari will not be suitable in this case, but let take an example that women or girls wearing saris are kept into a different cluster, and then uh, persons who are having a funky haircuts put it into another cluster. Again, the cluster is female and male, then that will be another cluster. So we are having these unlabeled clusters, right? So now I tasked my machine that you already learned supervised labeled and unlabeled data. Now get this leaker and serve to them who are having funky hairs. So what that machine will do, machine will analyze all the clusters who are having funky hairs, labeled and unlabeled both them. And then the machine will only offer leaker to those persons funky hairs, which is already determined by the unsupervised. That's how unsupervised learning works. The best example for body parameters to be analyzed it is a aiming. Aiming you can use for a machine learning, which will give you the most appropriate average things because you wanted to see the average. I have 100 people, that 100 people who are having funky hair. So you will be taking the average. Aiming is a possible solution. You can try to. Here so far? Okay, can we move ahead? Now, another best example of unsupervised learning, the characteristics what we just talked about, that maybe one of us not watched football ever, and this is the first time I'm watching football. But so I'm starting distinguishing the players. I wanted to distinguish both the parties, Mumbai and Pune people. So what I'll do is I'll started with the first thing, what type of uniform or what type of jersey is this players are. But one type of jersey they are having green shorts and yellow t-shirts. Okay, I'll keep them aside for one cluster, and I'll keep rest in one cluster. So I've distinguished these two things. So this can be a unsupervised learning. Maybe this can be a supervised learning as well. You can give a data set with the parameters like green shorts and yellow t-shirts are Pune, and for the rest is Mumbai team. You can give it like that. But if you are looking at the first basis, you are not defined any learning algorithm, then it can be a best example of unsupervised learning. Then unsupervised learning into banking sector, the segment customer by behavioral characteristics. Behavioral characteristics means what? You are not going to characterize your what we can say uh, your customers into your body language or anything. You will be characterizing them or you will be categorizing them based on the financial behavior. So that can be so yes, of course we are taking a break. We will be I think we will be take a break. Then we shall resume. Is it okay?
Hello.
And of course, we will be having a practical session on tomorrow where we will be covering how to supervise and supervise reinforcement with the TensorFlow algorithm. So you all guys will be having practical at the machines. I'll be sharing applications and how to install them and every instruction. Okay, guys, then see you at 12 exactly.
Hello, Amey sir. 20 minutes break.
Hello.
We'll take 20 minutes break.
Yes,
We'll take 20 minutes break.
yes, we'll take a 20 minutes break. We'll be back by 12. It
Okay.
is 11:33 now.
Yeah. Okay, we'll start the session at 12 o'clock.
We'll start the session by 12. Thanks. See you then.